Okay, welcome back. So hopefully you like this video because you've been through the video about hyperbolas or you found the concept in that video way too simple. Anyway, we're going to be looking at this equation over here and we're going to be trying to sketch it on the y and x-axis. Now you may be thinking, what's going on? Isn't this just two linear functions? We should just, I don't know, do something funky with linear equations. Well, it's probably not the case. When you have one algebraic expression over another two polynomials, you can simplify it a little bit further using a bit of long division. And you can probably guess from all of this white space over here and the graph over here, this means that there is a little bit of algebraic manipulation that we need to go through before we can sketch this effectively. So let's see what's going on. If we have one linear divided by another, this is the same as saying 7x plus 2 is divided by 5 minus 3x. Now I can write 5 minus 3x here, but since we're doing long division of polynomials, let's try saying negative 3x plus 5 instead, just so we have the highest order term right in front. So we do this, 7x divided by negative 3x, needs a little bit of fraction work over here, but let's put it on the side. So we need something multiplied by negative 3, so this is the unknown here, equal to 7. Now, you can of course just do the reverse process, say 7 divided by negative 3. So we need to multiply through by negative 7 on 3. That's how many times this one over here goes into the expression inside our division zone. So we have negative 7 on 3. That's our quotient. And we have 7x here. Since we multiplied through by negative 7 on 3, we need to multiply this positive 5 by the same amount. So we're going to get negative 35 on 3. And of course, you can see that this one isn't a perfect factor of 7x plus 2. So we can find the remainder here. 2 minus negative 35 on 3. So this one over here is 6 on 3. So this means our remainder will be 41 on 3. Okay, so that's our remainder. So what's going to happen next? Now, we need to rewrite our expression using the information that we found. We know that this expression goes into 7x plus 2, negative 7 on 3 times. And what's remaining is positive 41 on 3. So remember, that can be considered your numerator of the fraction that you have left. And this still is yet to be divided by 5 minus 3x. So we're going to chuck that on the bottom. So we're very close to the correct form for a hyperbola. Because recall that the form that we want for a hyperbola is something like this. Just for reference. Okay. So we can see that x is by itself. So two approaches here. And you can use whichever one you're comfortable with. Either make your denominator, so we make 5 minus 3x equal to 0 for asymptote. But remember that you can find your asymptotes by simply looking at the translations after you manipulate your expression over here. So I'm going to try to get this into this form over here, just so we can see the whole big picture. So what we're going to do is, we're going to use this big term first. So we know that 41 on 3 is our a value, divided by, we're going to take a factor of negative 3 out. So we have negative 3, and x is finally 3. This is what I call the lonely x rule. We need the coefficient of x to be 1. And when we take negative 3 out, negative 3 times y is equal to 5. Minus 5 on 3. And of course, don't forget about your constant here, theta. Minus 7 on 3. And from here, we can talk about all the translations that are happening here. So, all the transformations. So we got dilation from the x-axis equal to 41 on 3. We got oh sorry, it's not 41 on 3, it should be 41 on 9, because we need to consider if this 3 is chucked to the top over here. Okay, and we also got horizontal translation of 5 on 3. And for the vertical translation, we're simply looking at the k value here. You see it's negative. Negative 7 on 3. Okay. And since we have a negative over here, now, maybe I'll just rewrite all this out just to be clear. But this one over here, what is it wrong? If you want to take the negative 3 to the top, it's a little bit clearer what the a value is. A value is 41 on 9, or negative 41 on 9. This is all over x minus 5 on 3. Minus 7 on 3. You can see over here, when you compare these two, that the magnitude of the a value is 41 on 9. You have a negative a value. This also means that there is a reflection. Is there a reflection on x-axis, reflection on y-axis? Either one works for hyperbolas. Remember, they're the same thing. Okay. So from here, we can sketch using all of this information here. Okay. So I'm going to take out a blue. So we move to the right by 5 on 3 units. So this means our asymptote used to be at y is equal to 0, but now it's shifted to the right. So y is equal to 5 on 3. Our vertical translation, we're shifting it down by 7 on 3 units. Used to be at y is equal to 0. Sorry, this is x. My mistake. So our horizontal asymptote is now shifted down to y is equal to negative 7 on 3. And the dilation over here, you don't really need to express this because the dilation is implied by where the intercepts are. So the intercepts actually tell you how much your graph is stretching outward. So we're going to find the intercepts next. I'll do it in this bottom corner here. Okay, so y-int, generally the simpler one for functions. X is equal to 0. And you can use your original expression for your equation here, or you can use your modified one. Either one doesn't matter too much. Just use the top one because it does look a little bit simpler to work with integers. Y would equal to 0 plus 2, 5 minus 0. So 2 on 5. And we also have our x-intercepts. So this is when y is equal to 0. Okay. So the left-hand side is now 0, and we need to solve for what x is. So we've got 7x plus 2 over 5 minus 3x. But wait, hold on. This equation here is independent of what the denominator is. So if you multiply both sides by 5 minus 3x, this gets cancelled out. So this means our x-intercept has to be negative 2 on 7. Okay, so let's plot this out. 2 on 5, so that's about over here somewhere. Doesn't have to be to scale, remember? As long as you have all the key points. This one over here, negative 2 on 7, so just a little bit to the left of the x-axis. And we got it here. Negative 2 on 7, 0. And we simply want a graph which passes through both these points. And another one down here. Okay, and you can see that since these intercepts are in the second quadrant, it does show that your hyperbola has been reflected in the x-axis, and you're also going to have one over here because you had your reflection. Okay, so just to reiterate, these 2 points already show what the dilation is, so you don't need to plot another point using this equation to show your dilation. These already show how much your graph is being stretched. Okay, I think that's as difficult as it gets for hyperbolas. Just going to do a bit of long division. Sometimes when the question asks you to graph, just remember that doesn't mean that you don't have to go through a bit of algebra.